Welcome back. This is day 5. We're going to be looking at Newton's third law, the third and final law that we have for Newton. There's a law of gravitation, but we're not going to focus on that. So Newton's 3 laws, we already did 1, we did 2, and now we're on the third one. The third one says the third law says for every force applied, there's an equal and opposite reaction. Okay? So if I apply a force on a box, that force on the box is applied back on me. Now, the reason why I'm able to move the box and the box not me, because I have friction, more friction than he does, and therefore I'm able to push the box because of the friction I have with my feet. Now, if I was on ice, I'd push the box, we'd both be sliding away from each other. It'd be crazy. But we're not on ice, and therefore we have some friction between our feet and the floor. So, for every action force, there's an equal and opposite reaction force. And we always write this as FA is equal to negative FR. So FA and FR are the same number, but FR has a negative sign. Okay? So the force applied is always equal to the negative reaction force. So, like I said, if I push on the wall's pushing back on me. Now, why isn't mine not moving? Because I'm not applying enough force. Or why am I not moving the wall? Because I'm not applying enough force. If I tried really hard, my feet would slip and I would fall, right? Because the wall is cemented into the ground, and I have less friction than the wall does. The wall has a lot more friction. It's also got more mass. So when you think about a linebacker, think about a linebacker, right? So he's going to be buff or center. If he goes up against some kid that runs cross country or something, or think about a football player, a professional football player of 300 pounds going up against a 5-year-old, like my 5-year-old, okay? So, boom, who's going to get bounced back? My 5-year-old is going to be flying backwards when the football player has more mass, therefore he's got more momentum. The forces are applied equal, but there's going to be a bigger reaction force on my son than there is on the football player. All right, so we're going to do a simulation on that too. It's actually one that involves teeter-totters, so involving my son being on a teeter-totter. So let's check it out. So you're going to go to day 5. Right after this, you're going to run the simulation. Now, this one runs in your browser also, so you don't have to worry about downloading and doing stuff. So we have an introduction, we have a balancing lab, and then we have a game. So I'm just going to do straight to balancing lab. Okay? So let's do the balancing lab. So right now I have cylinders on both sides holding up my teeter-totter. I can put objects on my teeter-totter wherever I want. Okay? I can put 20 there. Let's do 15 here. And then we're going to find out what happens when I take away. Oh, we know what happens. 20 is greater than 15. Let's put those back. What if I put that there and I put that there? 20 is closer to the center. Therefore, it doesn't have as much pull on that side. What if I move this guy over one more? Oh, not quite. One more. Oh, he's a little bit more. Well, we can take 10. We can take, we can take 10. We can take 5. And we're going to try it out. Oh, okay. So this balancing lab activity, you can do rulers, measuring, decide where you want it, marks, 1, 2, 3, 4, 5, 6, 7, 8. You can show the force of the objects as they're on there. So, boom, it's got a force. You can show me if it's level based on that. Okay. You can also go back to this one. This gives you fire hydrants and a trash can to play with to see how that works. If you so feel inclined after you do your lab, you can play some games and see how well you are with balancing the teeter-totter. So, we're all talking about the action-reaction. So, if one object's going down, the other one's obviously got to come up. Okay? Every action, there's an equal and opposite reaction. That's why we're looking at this balancing game. All right, guys. I'll see you guys later. Take care.